Good morning, world. Welcome back to your channel Patsala. Today we are going to learn class 11 chapter power, work, power and energy. Today we are going to calculate there is steps and we are going from down to upwards and also repeat the process by using a ladder. What we see, there is the same work done. Yes, you asked me why it's happened. Hmm? The going towards using the steps or ladder, there should be work done same. There is no path dependent dependent on the initial point and the final point. Positions only or depend on the position. Dep- there is no dependency on the path, and this is called the conservative force field. So you are going upwards or using the ladder. What happened? There is the work done. The work done is gravitational force field. So first write the chapter name, work, work, energy, and power. Work, energy, and power. Let's continue. First, we learn the calculation. We know about the gravitational force field. Is it conservative or non-conservative? Gravitational force is conservative force field. Now we are going to prove that. Let us consider an inclined plane. This is the inclined plane, A point and B point, C point. So the inclined plane is AB. What you were doing there? Just you were climbing from the point A to B using the inclined plane. And how you are climbing, your weight is acting downwards direction mg, and angle theta. Let us consider the angle of the inclined plane is theta, and you are climbing using the practice hard work, and you reach the goal. Just using the example how to reach the success. Let us consider your mass is small m, and the angle of the inclined plane is theta, and there is a weight acting downwards direction, and let us draw another straight line. That angle should be theta, and that component is mg cos theta, and there is mg sin theta along the inclined plane, and the inclined plane is frictionless, sin theta. Just write it There is a frictionless plane. Now you are climbing through the or climbing over the inclined plane. AB, let us consider the length of AB is equals to S, and work done is equals to force, that is mg sine theta, acting along the inclined plane, into displacement S. Now what happened here? That is equals to mg s sine theta. Now finding the sine theta from the triangle ABC, let us consider the BC is small h height. Now find the sine theta. Sine theta is equals to h by s. That's perpendicular by hypotenuse, h by s. So we have the sine theta. Now putting it in that equation, mgs into h by s, and ss will cancel out. We have mgh. That is the work done along the inclined plane AB is equals to mg into h. Now there is a ladder. ये ladder है. Now you are using the ladder to climb from the point C to B. Your weight is acting in the downward direction mg, and you are going a distance of s. That is W of BC is equals to mg into h into h. That is equals to mgh. So we have the work dones are same. It is dependent on the A initial point and the final point B. That is the final point. And the total work that depends only on the initial and the final point, not on the path we used. Now let's see it again with another example, elaborating it. This is A point, this is B point. Now let us consider the path nature differently. A to B, and another path A to B, and another path A to B. Now let us consider A to B work, W1 work done, W2 and W3 work done. And here the W1 is equals to W2 equals to W3. It only depends on the initial and the final point, not on the nature of the path and not the way you used it. You understand that concept? Now we are going to non-conservative force. The non-conservative force, if you choose the different paths, the work done will not be equal. It depends on the path you chose. W1, W2 and W3 are the works done for the different paths. So here W1 not equals to W2, not equals to W3. So what we know from that, and that non-conservative forces depends on the path. The work done of the non-conservative force is dependent on the path. And what are the examples of non-conservative forces? Frictional force, frictional force, viscosity, air resistance force. Okay, now you understand? Huh? Frictional force, viscosity, and the air resistance. Yes, they are the non-conservative force. Total loop. If you used the total work done, this is B point. The closed integral f dot dr, that is not equals to 0 for the non-conservative. If we consider the conservative force, the cyclic work done, f dot dr, that is equals to 0. Yes, f dot dr, the work done by the conservative forces is equals to 0 along the loop. Okay, we can prove it easily. Now let's consider you are standing on a roof and your friend coming to discuss some topics learned from the Pathsala, and there is a copy of Pathsala. He first going upwards to you from A point to B point. Yes, you are solving numericals barabar, etc. Now you are going from the A point to B point, and again after solving the questions he comes from the B point to A point. Now consider W of AB, that is equals to mg, and height is h, where the force is acting in the downwards direction and you are going in the upwards direction, so minus mgh will the work done. Next, you are coming from the B point to A point, BA, that is equals to mg is acting in the downwards, in the direction of your displacement, that is mgh. Adding up this W of AB plus W of BA equals to 0. mgh plus mg, that is equals to 0. Okay, na? Yes, in the total cyclic path the work done becomes 0. You understand that concept? Okay. Now we are going to discuss work done by variable force. We discussed about the work done by variable force. We write F, capital F, that is a force dependent on x. This is the axis. Along the y-axis we have the fx, and along the y-axis we have the x. Now draw the graph, that is the graph. This is a variable force. In everyday life we use the variable force mostly. Now taking a strip, that is a strip we have, and that's with is dx. So we are going to write that is work done is equals to dw f dot dx, fx dx. Length of the breadth and the initial point at the position of xa, and the final point is at the xb. Now total work done we integrate from the point A to B, that is integration fx dx, and integrating from xa to xb. Total work done fx dx due to variable force. If that kind of the problems is given in the exam, work done is equals to area under the curve or the graph. Okay, na? That will give you the work done. Okay, now proceed upwards in the forward direction with the some another concepts. And there is a progressive world around us, and we need the energy to progress in life. What is energy? The capability or the capacity of doing work is the energy. Now, you are having a lots of energy to, and you will cross all the barriers to become a successful in life. Okay, so we divide it into the two parts, kinetic energy, and number 2 is the potential energy. What is kinetic energy? We are running potential energy. Hey, one, yes, if you are moving, you have energy. That energy is kinetic energy. Now what we are going, find the expression of the kinetic energy. Kinetic energy, that is equals to, let us consider, now we're going to, let us consider an object over a surface. It is at the rest and the mass is m, and a constant force is applied on it, capital F, and its final velocity, let us consider, its final velocity is v. Now the work done is equals to F into S. F equals to M into A into S, and V square is equals to U 0 square plus 2S, that is A is equals to V square by 2. Now putting it in the equation, we have M into V square by 2, that is the kinetic energy formula. Okay, for the constant force. If it is a variable force, this work done W, if it is work done, W is equals to integration F into ds. See, force and the displacement are in the same direction, so F ds cos of equals to F dot ds, that is equals to integration F ds cos 0 degree. Cos 0 is 1, F into ds, that is equals to M into A dv by dt, that is A is dv by dt into ds, that is equals to M dv into ds by dt. So integration m into dv into v, the integration m v dv 0 to v, and integrating it we have m into v square by 2, that is half m v square. So we have the kinetic energy formula. So today it is enough, and we will discuss about this lecture elaborately about the energy conversion and let's wait for the next class and we will discuss about it. Please subscribe and like, and please press the like icon. Goodbye for the day.